the results are summarized in this table, and this table 1 is for the only for the fast bowlers. So we have fitted T probability distribution, and these are the estimated parameters and log likelihood values, AIC, BIC, and case test P value. So from this table, we can see that gamma distribution is a best fitted model over the other two distribution, log normal and Rayleigh, for all the fast bowlers. And similarly, we have fitted the same distributions to the spin bowlers also, and the same result we came that the gamma distribution follows the best fitted model compared to the other two distribution, that is log normal and Rayleigh. And since gamma distribution, we found the best fitted model. Based on gamma distribution, we have calculated the mean and variance of different fast and spin bowlers. And here, these are the results. That is the average economy rate of the different fast and spin bowlers. And among fast bowlers, we have found that Jasprit Bumrah shows a much lower mean economy rate of 5.68 and a relatively low variance of 5.44, indicating both economical bowling and consistency. For spin bowlers, Adil Rashid has the most economical bowling with a mean of 4.69 and the lowest variance 3.64, highlighting his consistency and control. Now, next, we have found that for these bowlers, the gamma distribution is the best fitted model. So next, our aim is to check whether there is any change in their mean economy rate. So for this, in this section, we have checked whether there is any sense point exist in their average economy rate. So a sense point signifies a shift in the underlying pattern of economy rate, such as the sudden improvement or decline in a bowler's efficiency in minimizing runs, which can result from changes in playing conditions, strategy, player fitness, or opposition strength. Identifying such points helps analysts, coaches, and selectors to assess consistency, detect phases of form or decline, and make data-driven decisions about team composition or player training. So therefore, estimation of sense point in the economy rate and its associated parameter plays a crucial role in understanding the dynamics of a bowler's performance in cricket, particularly in the format of 2020 matches. So I have already said the gamma distribution is the best fitted model for all the 10 bowlers. So here is the PDF of gamma distribution. It is written 3.1. Now, if x1, x2 up to xn is a random sample, that is the economy rate of a bowler in different matches that follows a gamma distribution, then the likelihood function is L naught, x given the set parameter alpha and red parameter lambda, which is given in equation 3.2. So next, suppose x1, x2 up xi plus 1 up to xn be the economy rates of a bowler in 1, 2, xi plus 1 up to n matches. That means he has placed n matches, and x1, x2 up to xn are the economy rates in different matches. And suppose that there is a change in economy rate after playing xi match. That means x1, x2 up to xi follows gamma distribution with parameter alpha and lambda, and after the point xi, xi plus 1, xi plus 2 up to xn follows again gamma distribution with different parameters, suppose say alpha b and lambda b. And their distributions are given in equation 3.3 and 3.4. Here there is a typo, it is not x given, it will be x semicolon actually. So therefore the joint likelihood function is given by the equation 3.5, which is denoted as L1. Now, how to estimate the parameters? Here we have discussed about the maximum likelihood estimation, a procedure to estimate the parameters of this distribution. The likelihood function is then given by, log likelihood function is then given by equation 3.6, that is log of L1. So to obtain the maximum likelihood estimators of alpha I, alpha B, lambda B, and xi, there are 5 parameters here now. We take partial derivatives of the log likelihood function with respect to each parameter. And these are the first derivative of log of L1 with respect to different parameters, that is alpha I, that is alpha B, and lambda A, lambda B, where psi of alpha A and psi of alpha B are digamma functions. By equating the equations 3.7, 3.8, 3.9, 3.10 with 0, we can obtain the maximum likelihood estimates of the parameters, that is alpha A kept, alpha B kept, lambda A kept, and lambda B kept. Now the estimate of xi is the value that maximizes the log likelihood function, where alpha A equal to alpha A hat, alpha B equal to alpha B hat, lambda A equal to lambda A hat, and lambda B equal to lambda B hat, and xi hat equal to arc maximum of log of L1. Now, simulation results of these estimates. We conducted a simulation study to estimate the sense point and the associated parameters before and after the sense point. The simulation results in these sections are obtained using Monte Carlo methods with 1000 iterations. So here is the results of simulation. We have conducted the simulation procedure for different sample sizes and different sense point with different parameters, which is the sample size is 50 per sense point, considering 25 for 100. The sense point we have considered 50, like this way, 150 to 100, and considering different parameters. And from the table, it is evident that the estimated parameters closely approximate the true values, with root mean square errors consistently decreasing as the sample size increases. This indicates greater estimation accuracy with larger samples. Importantly, the estimated sense point also converges toward the true value as n increases. Overall, the simulation validates the effectiveness of the estimation procedure, particularly with increasing sample size. So next, here we have found two models. One is with sense point, one is without sense point. First one is without sense point, next one is with sense point. Now to check whether these two models have significant difference, that is, after this, is the sense point is significantly, is there any significance of the sense point in their mean economy rate? We have performed likelihood ratio test. So here the null hypothesis is H naught alpha 1 equal to, it is alpha 2 equal to alpha n equal to alpha. That means H naught is for the H naught supports the hypothesis of without sense point. That means it follows gamma distribution with parameter alpha and lambda. And H1 is for the hypothesis of considering sense point. That is, before the sense point, the parameter is alpha and lambda, and after the sense point, the parameter is alpha b, lambda b. And therefore, the likelihood ratio test statistic is defined as delta equal to supremum of L naught divided by supremum of L1, which is given in equation 4.3. Now, taking the natural logarithm of the likelihood ratio statistic, we obtain log of lambda equal to, which is given in equation 4.4. So here alpha A hat, alpha B hat, lambda A hat, lambda B hat, and xi hat are the maximum likelihood estimate under the respective hypothesis. So next, we have estimated power for likelihood ratio test. So to detect a sense point xi, we assume that the parameters of the distribution sense from alpha A lambda A to alpha A plus delta lambda A plus delta after descent. To assess the performance of the proposed hypothesis test based on the logarithmic likelihood ratio, we conducted a Monte Carlo simulation to estimate the power of the test. And since the distribution of the log likelihood ratio under the null hypothesis is not available in a closed form due to the model's complexity, we use a non-parametric permutation test to approximate it. And we generate 500 random permutations of the observed data under the assumption of no sense. For each permuted data set, we compute the log likelihood ratio, thus constructing an empirical distribution of the test statistic under H naught. So here is the empirical distribution of log likelihood ratio. The figure represents the empirical distribution of the test statistic under the null hypothesis H naught. The vertical line in the histogram marks the critical value corresponding to the upper alpha quantile, that is the 95 percentile for a significance level of alpha equal to 0.05. So this is the curve for power estimates. This shows that the estimated power of the test for different values of the sense magnitude delta across various sample sizes. So as expected, when delta equal to 0, meaning there is no true sense in the parameters, that means there is no sense, the power is approximately 0.05, which corresponds to the probability of type 1 error. This confirms that the test maintains the correct level under the null hypothesis. That means when delta equal to 0, the alternative hypothesis is same as the null hypothesis, and in that case, the probability of type 1 error is equivalent to the power, and which already we found from this curve for larger sample sizes. Now, here we have discussed about the sense points, whatever we have collected the data for 10 different players. So is there any sense point exist, and the procedure of estimation. So firstly, we have used CAMSUM method. The cum sum method, that means cumulative sum method, is a sequential analysis, and it is used in time series analysis basically. Used for detecting sense point in a time series, particularly effective in identifying shifts in the mean of a process. So for a sequence of observations, x1, x2 to xn, the cum sum statistic at time t is defined as s not equal to 0 and st equal to summation of xi minus mu, where mu is the reference or x actual mean. Therefore, xi equal to r, the maximum of st. So by using cum sum method, we have visually checked, graphically checked that is there any changes exist in the mean economy rates of the players. So from the figures, this is the figures for the fast bowlers, and these are the spin bowlers. And we have found this table that there are some sense point exist in their mean economy rates, and it is tabulated here. These are from cum sum method. Next, since sense point exists, so now our next aim is to estimate the parameters before the sense point and after the sense point, and to estimate the sense point exactly by using the gamma distribution. We have uh, estimated here the parameters considering gamma distribution, since gamma distribution found to be the best fitted model for this particular batsman's bowler. Sorry. So this is the table for estimate of sense point and associated parameters. That is here, xi kept is the sense point. That is for first are the fast bowlers and as well as the spin bowlers. And alpha A, lambda A kept are the parameters before the sense point, and alpha B kept and lambda B kept are the parameters, estimated parameters of after the sense point. So from this sense point, from these estimates, we have calculated the mean and variance before the sense point and after the sense point. So the results are summarized in this table. And from this table, it is seen that there is some changes after the sense point and before the sense point in their mean economy rates. So to check whether these changes are significantly different or not, we have performed likelihood ratio test. So from the likelihood ratio test, we have found that out of all the bowlers, only two bowlers, that is Jasprit Bumrah and Kagiso Rabada, for there, the null hypothesis is rejected. For all the others, we found that it is not rejected. That means Jasprit Bumrah and Kagiso Rabada has a significant sense in their mean economy rates. So the results are among the fast bowlers, the test reveals statistically significant changes in the economy rate distributions for Jasprit Bumrah and Kagiso Rabada, as the likelihood ratio test statistic exceeds the respective critical value, leading to rejection of the null hypothesis of no sense. Specifically, Bumrah shows a substantial decrease in mean economy rate from 6.65 to 5.28, while Rabada experienced a notable decline from 8.73 to 6.32, indicating marked improvements in their bowling economy after this sense point. Conversely, for Pat Cummins, Arshdeep Singh and Trian Bolt, the null hypothesis is accepted, implying that the observed changes in mean economy rates are not statistically significant, despite Bolt and Arshdeep showing downward trends. For spin bowlers, all players Adil Hussain, Rashid Khan, Ravi Bishnoi, Mitchell Santner, and Juzvendra Sahal failed to reject the null hypothesis, suggesting that the differences in their mean economy rates before and after the sense point are not statistically significant. Although fluctuations are observed numerically in their mean economy rates, Rashid Khan's mean decreasing from 6.24 to 5.45, these changes are not supported by sufficient statistical evidence. Overall, only two fast bowlers exhibit significant changes in mean economy rates after this sense point, highlighting the variability in performance dynamics and stability across bowling types. So we have come to the conclusion. So this study provides a comprehensive statistical analysis for estimating sense point and parameters before and after the sense in economy rates of bowlers in 2020 international cricket. By modeling economy rates using the gamma distribution and employing maximum likelihood estimation along with the likelihood ratio test, we successfully identified significant changes in performance for several players. While significant changes were observed for fast bowlers such as Jasprit Bumrah and Kagiso Rabada, spin bowlers exhibit relatively stable patterns with statistically insignificant changes. Simulation studies confirm the robustness and reliability of the estimation process and test statistics. Overall, the findings contribute meaningfully to sports analytics by offering valuable insights into performance dynamics. So these are some references, and thank you very much. So if you have any suggestion.
Okay, Dhruvo, thank you very much for your presentation.
Yes, sir. Is there any suggestion?
I think let us ask from the house if there are any questions. There is no question in the chat box. If anyone has some question on the presentation of Dhruvo, then you can please switch on your mic and then put the question or write in the chat box. But I do have some questions, Dhruvo. Let us see what the house tells.
Hello,
Yeah.
sir.
Okay, sir.
I'm Suresh here, sir. Sir, how did you choose
Yeah. Yes.
the players for this analysis, sir, to carry out this work? There are many other bowlers also, but you have chosen only few fast bowlers and few spin bowlers.
Yes, sir. It is randomly chosen.
I see. Okay.
It is randomly chosen, sir. There is no technique to no technique not means, sir. I have
And
randomly
how about
chosen to.
you have considered all the hello?
Hello. Yeah.
The
Yeah, sir.
data
You
that
are
is
able
been
to.
used pertaining to the corresponding player, hope you have used the entire data set, right? All the matches played by the corresponding bowlers or players.
Not all the matches, but I actually forgot how many matches we have considered, but maximum of the 2020 matches.
The matches, all the matches played by the bowler, the players, were they considered for this study?
No, 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 not all, sir. They are still playing.
They are still playing, but by the time you started this analysis, up to that point, when you started the analysis, now till that point, how many matches they played? Did you consider the information from all those matches?
Yes, sir. That information I have, but I have not put in the slides. Actually, this is I have not till now. Till now, it is not complete. So I have just presented uh, to check what is the sample size for each player. I have to verify it. In it is that I have to check that what actually it is different for all the players.
Okay, sir. Thank you, sir.
Okay, Sureshji, thank you for your questions. Is there anyone else who may want to ask some question to Dhruvo? Okay, Dhruvo, I think there is no other question. We cannot see any question in the chat box also.
Yes.
Devenderji, you have some question?
Sir.
Devenderji, you have some question?
No, sir. No. Good morning, sir.
Good morning, sir. Good morning. Dhruvo, 2 points are very important. Sureshji was mentioning. First is that when you select the players, generally in cricket analytics, what happens, or in analytics, we have to see that the player has sufficiently played some matches. So we put a rider that this player is currently playing or has played at least this many number of matches, at least 50 matches. Some criteria we put, and then based on those criteria we make a selection. So if you select randomly, then a player may come who has played very few matches. For example, you have taken the example of Ravi Bishnoi. He's a nice bowler, good bowler, and now you can tell that he had played many matches also. But the problem with Ravi Bishnoi is that he is always not in the team. You may find that he is playing for 2-3 matches. After that, he is giving this place to Kuldeep Yadav, or say Jajwinder Chahal is coming in the team. He is dropped out. Then once again he plays. So this is he's a good example to start with. But then he has a lot of gaps in between. Means he is not playing regularly. So he is playing at a irregular intervals. So Ravi Bishnoi is not a good. So this is one thing that you need to consider.
Sir, can I add few more things to what you said, sir? Bhattacharya,
Yes.
sir. Yeah, that is what, as you said, that one of the criterion what they can choose is at least few matches, 100 matches they have played till now for the study. Either you can take a random sample of those players who have played at least 100 matches or some criteria
Yes.
like that.
That is some
If not
conditions
100,
are there.
something else.
Yeah, conditions are there. That is a means key point of any sports analytics, so that people have played a significant number of matches. Okay, and then you can do randomization. Yes, Surajji is right. Acha,
Sir, you are muted.
Okay. Okay, Dhruv, I have one single question, few questions. You have assumed that there is, means try to find out whether there is a change point and you have searched for only one change point. So I
Yes.
understand that you are at the preliminary stage of this work, but it is better, means at a later stage you try to find out that whether there are, detect whether there are multiple number of change points. Because what I
Yes.
tell, what happens with a bowler, whenever he comes and enters the team, initially he is a lot, not having much experience, and his position is also not very regular. Means like this Ravi Vishnu type of bowler, means in and out of that. Then he stabilizes. So when he stabilizes, he has a stable economy rate and stable strike rate, bowling average, etc. Then he improves in his career. Otherwise, he will be dropped out of the team. So he generally a long player with a long career generally improves. And then at particular time, aging comes up because of aging, because of his performance getting down, and then regularly he is not performing well, and then generally he is dropped. So basically, if you look at a player's career, bowler's career, who has played say more than 100 or 200, around more than 100 number of matches, ideally there will be at least two change points. One when he actually means settles down. Initially he has some hiccups, then settle down, then stabilizes, and then once again his performance falls down. So there might be means generalized way at least two change points. There can be more also because some players are very irregular, sometimes in the team, then drop, then once again in the team. So at one stage, you please try to improve your model so that first you detect the number of change points that might be available in the career of the player, and then you go for